Good morning, and welcome to Parts of a Right Triangle, where we will be talking about the Pythagorean Theorem. Let's go ahead and start off the parts of a right triangle. Here in our picture we have three different letters, A, B, and C. Sides A and B are called legs, and C is called the hypotenuse. We always label the hypotenuse with a capital H. So I'm going to put a capital H right above the letter C. What is the Pythagorean theorem? The Pythagorean theorem is used to find a missing side length on a right triangle. You can only use this for right triangles. The formula, a squared plus b squared equals c squared. We're going to use this formula down here in some of our example problems. We're also going to have to manipulate the formula a few times. Let's take a look at number 1. Okay, the first thing that I'm going to do, since this is new to us, is label each of the sides. So our two legs are A and B, and the hypotenuse is C. And the hypotenuse is always across from the 90-degree angle. Always across from the 90-degree angle. So I'm going to write down my formula, a squared plus b squared equals c squared, and I'm going to plug in the respective numbers for each letter. A is 8, B is 7, and then we don't know C. That's what we're trying to figure out. So 8 squared is 64. 7 squared is 49. We set that equal to C squared. Let me get out my handy dandy calculator. 64 and 49 make 113. We set that equal to C squared. Now the question is, how do we get rid of a squared? Well, the opposite of a square is to take the square root. So, if I do the square root on both of these numbers, what happens here is this squared goes away, it cancels out, and I'm left with a C. So we have to take the square root of 113, and when we do that, we get 10.63. That's your answer right there. Okay, so what happens if we don't have C? Or if we have C, but we don't have one of the legs? Well, again, let's go ahead and label each of our sides. We got A, B, hypotenuse is C. Here's my dotted line. So A squared plus B squared equals C squared. Okay, I'm just going to plug in my numbers like we did the last time. A is 6, B is X, and C is 13. Okay, this does not look like the previous problem, but we can manipulate this equation right here to get something very similar. So let's go ahead and multiply everything out. 6 squared is 36, plus x squared is equal to 13 squared, which is 169. Now I need to get this x by itself. So I'm going to underline it, so that way we know that we're trying to get it by itself. I'm going to take away 36 from both sides. Now we have x squared equals 133. Remember, to undo this squared, we have to take the square roots. And this gives us x equals 11.53. Let's go ahead and do this. Number 5. This is going to be the last one that we do together. Go ahead and label my sides. A, B. Here's the hypotenuse. C. A squared plus b squared equals c squared. A is 12, so 12 squared, plus x squared equals 20 squared. 12 squared was 144, plus x squared equals 400. Take away 144 from both sides. Remember, the opposite of addition is subtraction. That's why we're doing this. These cancel out. X squared equals 400 minus 144. That's 256. Take our square roots. And that gives us x equals 16. Wow, what a nice number.